Study the sign of the following expressions. First of all, you have to keep in mind that the roots are the keys of the sign. So first of all, I have to find the roots of the factors. I will get x plus 1 equals to 0, then x equals -1, and here minus x plus 2 equals to 0, and x will be equal to 2. Now I'm going to set up the table of signs, starting from the domain of definition, which is negative infinity, positive infinity, since we are dealing with a polynomial. Right here will be the first factor, x plus 1, the second factor, minus x plus 2, and we have the roots -1 and 2 from left to right. -1 is smaller than 2. Then we know that the root of x plus 1 is -1 and the root of minus x plus 2 is 2. According to studying the sign of first degree polynomial, it will be opposite before the root and same after the root. Right here, the leading coefficient is 1, which is positive, then the sign will be negative, positive, positive. While in the second expression, we have the leading coefficient is negative, opposite of the negative will be positive, here positive, then negative. And here will be x plus 1 into minus x plus 2. Then I have to multiply the signs. It will be negative, positive, and negative. Right now he said study the sign. Studying the sign, I have to check when this expression is positive and when it's negative. So we will say that x plus 1 into minus x plus 2 is greater than 0. I will check where do we have the positive sign, right here. Then for x belongs to -1, 2. X plus 1 into minus x plus 2 less than 0, right here, which is over 2 intervals, then x belongs to minus infinity minus 1 union 2 plus infinity. And of course we can state that x plus 1 into minus x plus 2 equals to 0 for x belongs to -1 and 2. In the second expression, the same. First I have to find the roots of x plus 2 and 3 minus x implies x equals to -2, and right here we have 3 minus x equals to 0 and x equals to 3. Then I have to set up the table of signs, starting from the domain of definition. I have the roots -2 and 3, and of course we know that -2 is less than 3. The factors x plus 2 and 3 minus x, and don't forget that I have -2 right here. Here I will call it the product of these three factors. But first of all, let's study the sign of each. The root of x plus 1, x plus 2, is -2, then opposite sign as the leading coefficient will be negative, then same will be positive. Right here the root is 3, then the opposite of -1 is plus, positive, and right here I have negative. And of course we know that -2 is always negative. Right here I have the zeros. Multiply as product the signs, I will get plus, minus, and plus. Right now I can slide the sign directly. We can say that -2 into x plus 2, 3 minus x is positive. Directly I have to check the positive sign, which is right here. I can use this operation greater than or equal to 0. So directly we'll say that x belongs to positive, then it's over this interval and this one. So x belongs to minus infinity till -2. But since we have or equal, so -2 will be closed, union, the second interval also closed since we have equals to 0, till 3, till plus infinity. And the same expression is less than 0 if x belongs to, right here we have negative, then right here is the interval, so x belongs to -2, 3. Why it's open? Since we have right here strictly less than 0. For this one, the third expression, the same. The product of signs is the same as division of signs. So in order to study its sign, I have to find the roots. First of all, the root of the numerator will be x equals to 5. The root of the denominator, x plus 4 equals to 0, implies x equals to -4. Can we talk about the root of denominator? Yes, I'm talking about the root of the expression x plus 4. Later on we'll check whether it's accepted or rejected or it's outside the domain of definition. Right now, after finding the roots, I will talk about the table of signs, x minus infinity plus infinity. This is the domain, but also we have a restricted value which is -4. -4 will be a restricted value which is the root of the denominator, and right here we have another root which is 5. Let's see. For the expression x minus 5, the root is 5, and for the expression x plus 4, the root is -4. Till now, yes, it can be 0 as a first degree polynomial x plus 4. But when I'm talking about x minus 5 over x plus 4, right now the value will be restricted. But 5 is a solution of this, or root of this fraction. Right now I'm studying the sign x minus 5, opposite right here, which is negative, since I have plus, and here positive. X plus 4 also negative, then positive. The signs will be plus, minus, and plus. And right here I have equal to 0. Solving this, studying the sign, of this expression, I will get that x minus 5 over x plus 4 is greater than or equal to 0. And here you have to pay attention. Positive right here, but I have or equal to 0. Here I have equal to 0, but at -4 it's a restricted value, so it should be excluded. So we'll say that x belongs to, starting from minus infinity till -4, which is outside the interval union. The second one right here, since I'm talking about or equal, then 5 right here, which is the root, will be included from 5 till plus infinity. And this expression x minus 5 over x plus 4 is strictly less than 0. For x belongs to, right here we have negative, which is between -4 and 5.